As you can see, NAT provides a really great service for IPv4. However, it does have its limitations. And one of those limitations is related to end-to-end visibility. If we have applications or services that require complete end-to-end visibility, well, they lose the end-to-end visibility because of network address translation. That router is changing the packet. It's changing what is truly seen from end to end in that network. So those applications or services that we have or features are no longer functioning as we intend them to. And it's quite possible that they won't work at all. Tunneling becomes more complex. Think about a VPN tunnel with IPsec. What can it do? It can do data integrity checks on the IP packets. Well, if you're using network address translation, are you changing the packet? Yes, you are. And when you change a packet, what happens? You're changing the integrity of the packet. It's no longer the original packet that was sent. Therefore, according to the tunnel, according to IPsec, it's no longer the same packet, making our tunneling configurations and our tunneling operations much more complex because we have to be aware of this problem and we have to solve that problem. Another big issue we have is the topology we see on screen. So everything's great for the customers, the public users out on the internet. What's going to happen here is they're going to type in www. whatever the address of our web server is, and they're going to get a response from DNS about the public IP address. And the public IP address is going to be the public IP address of, for example, this particular outside interface. So here's what happens. They send their packets, it arrives in, they get translated to the address inside on our web server. So we're using a private IP address inside on our web server for the translation process. And then everything gets translated back, and everything's fine. However, from our internal clients, things aren't so rosy for them. And here's the reason why. They send a packet, and that a packet arrives at the router. And what does the router do? The router looks at the destination IP address. And what is the destination going to be? It's going to be the public IP address of the web server, because we would have typed in www. whatever the web server's URL is, and DNS would have given back the public IP address. So the destination is the public IP address. The source is our private IP address. So the router does routing first. So we route it to the exiting interface. And then we do network address translation, meaning that the private IP address is now converted to the public IP address that is necessary, and then the packet's sent on its way. How does it get back in and down? You see with the problem here, the order of operations, routed first and then translated. Routed first and then translated. We can't get that packet successfully back to that inside interface where the web server is.